Hello, I'm Spiros Miselis. I will be presenting full rates of exercise throughout the year for IB exams, and I hope it helps your case. Hello again. We continue with Chapter 1 and the mole concept. In the third category, we study relationship between quantity of chemical compound and its component element. Let's see first the informations of a molecular formula. When we know a molecular formula, we have a lot of informations. Example, the molecular formula of ammonia is nitrogen hydrogen 3. We have 1 mole of ammonia or 17.04 grams ammonia or L molecules ammonia contains 1 mole of atoms nitrogen or 14.01 grams of nitrogen or L atom nitrogen and 3 mole of atom hydrogen or 3 times 1.01 equal 3.03 grams hydrogen or 3L atoms hydrogen. We know, of course, MR of ammonia, AR of hydrogen, and AR of nitrogen. Let's study a lot of examples. One, how many atoms of hydrogen and how mass of oxygen contains in 4 mole sulfuric acid. Let's see the solution. First, we take the information of the molecular formula. 1 mole of sulfuric acid contains 2 times 6.02 times 10 in 23 atoms hydrogen and 4 times 16.01 grams oxygen. We select atoms and grammar because we're interested. In 4 mole of sulfuric acid, we have N atoms hydrogen and M grammar oxygen. So we can have the result 1, 4 is and we find the value of N. N is equal 28.16 times 10 in 23 atoms nitrogen. Also, we have the relation which gives the grammar of oxygen and the result is 256.16 grams of oxygen. So we study the first example. Let's see example 2. Quantity of calcium phosphate with this chemical formula contains 0.8 mole of oxygen atoms. Calculate the mass of calcium phosphate and the calcium atoms. We have also an exercise between the relationship of chemical compound and element component. We're interested about mass of calcium phosphate, so we first calculate MR. So we have for calcium phosphate, MR is equal 3 times AR of calcium plus 2 times AR of phosphorus plus 8 times AR of oxygen is equal 310.18. Let's have the relationship of molecular formula. 1 mole is equal with 310.18 grams of calcium phosphate, contains 3 times Avogadro constant calcium atoms and 8 mole of oxygen atoms. So we want m grams of calcium phosphate, n atoms of calcium, and we have 0.8 mole atom oxygen. So we have the relationships which have the information of molecular formula, and we find first the mass, third one 0.18 grams of calcium phosphate. Also, we have the second relationship, from which we calculate the number of atoms of calcium. And the result is 1.806 times 10 in 23 atoms of calcium. This is the solution. Let's see the third example. Quantity of calcium chloride contains 18.06 times 10 in 23 chloride ions. Calculate the mass of calcium chloride. Solution. We are interested about mass of the chemical compound, so we have first MR. For calcium chloride, we have MR is equal 1 times AR of calcium plus 2 times AR for chlorine. Then we take the relationship from the molecular formula. 1 mole is equal with AR grams of calcium chloride contains 2 times Avogadro constant ions of chloride. We ask for mass of the chemical compound and we know the number of ions. So we have the relationship which allows to find the mass. So we have M is equal so we have the mass equal 166.47 grams of calcium chloride. This is the third example. Let's see the number 4. Gaseous mixture of 0.8 mole methane and 0.2 mol ethylene how many hydrogen atoms contain? Let's have the solution. In this case, we're interested about mixture. We first define the composition of the mixture. For the mixture, we have 0.8 mol methane and 0.2 mol ethylene. We work with each component separately. First, for methane, we have the relationship 1 mole of methane contains 4 times Avogadro constant atoms hydrogen. In 0.8 mole of methane contains ni 1 atoms hydrogen. So we have and we have the atoms of hydrogen in methane. (4.816 times 10 in 23 atoms hydrogen. Then we go to the second component of mixture, ethylene. 1 mole of ethylene contains 4 times Avogadro constant atoms of hydrogen. In the mixture we have 0.2 mole ethylene and we can calculate the atoms of hydrogen. So we have the number of the second component. And 2 is equal the first number is equal 19,264 atoms hydrogen in the methane. So we have the total number of hydrogen. The mixture contains N1 plus N2 is equal 464 times 10 in 23 plus, and the total is 24.08 times 10 in 23 atoms hydrogen. Example 5. Aqueous solution of sulfuric acid contains 1802 grams of water and 2 mole sulfuric acid. How many mole hydrogen atoms and oxygen mass contains? Let's have the solution. We have again a mixture, so first we define the composition of the mixture. The mixture contains water 1802 grams and 2 mole sulfuric acid. We have grams, so you find mR for water. The first component is water. mR is equal 2 times AR of hydrogen plus 1 times AR oxygen. And this is the result. We take the relationship from molecular formula. 1 mole equal 18.02 grams water contains 2 mole atoms hydrogen and 16.01 grams oxygen. Now we have 1802 grams water and 1 mole atoms hydrogen and 1 grams oxygen. And we find first the mole of hydrogen atom, N1 is 2 times 1802 divided with 18.02. So the result is 200 mole of hydrogen atoms. Now we find the grammars of hydrogen. And the result is 1601 grams of oxygen. This is for the first component. Let's continue with the second component, is sulfuric acid. One mole sulfuric acid contains 2 mole hydrogen atom and 4 times 16 grams oxygen. How much contain 2 mole of sulfuric acid? With the same way, we find N2MM2. So we have 4 mole hydrogen atom and 128 grams oxygen. So we have the result. The aqueous solution contains mole of hydrogen atom hydrogen equal 200 plus 4 equal 204 mole. And mass of oxygen equal M1 plus M2 equal 729 grams. Let's see the example 6. Calculate the percent composition by mass of sodium hydroxide. Let's see the solution. We are interested for mass, so we find MR. For sodium hydroxide, we have MR equal with 40. Let's take the relationship between the compound and the chemical elements which contain 1 mole equal 40 grams sodium hydroxide contains 22.99 grams sodium, 16 grams oxygen, and 1.01 grams hydrogen. In 100 grams sodium hydroxide, we have M1, M2, M3. And we have M1, and M1 is equal 57.475 grams for oxygen the same way. And we find M2. And the result is M2 is equal with 40 grams. For hydrogen, we find M3 is equal to 0.525 grams. So, the percent composition by mass is and this is the result. Let's see example 7. Put the following in increasing order of sulfur mass .09 grams one mole hydrogen 2 sulfur 2 oxygen 7 Kl molecules aluminium 2 sulfur 3. We have again a relationship between the quantity of chemical compound and the chemical element sulfur. For hydrogen 2 sulfur, we find first Mr because we have grams is equal 34.09. 1 mole is 34.09 grams, contains 1 mole atom sulfur. The next compound, hydrogen 2, sulfur 2, oxygen 7, we have 1 mole contains 2 mole of sulfur atoms. The third compound, we have L molecules, and we know L molecules is equal with 1 mole. Contains 3 mole sulfur atoms. So we have the answer. First, smaller is sulfur mass in hydrogen 2 sulfur. Then sulfur mass in hydrogen 2 sulfur 2 oxygen 7, and the most mass is in aluminum 2 sulfur 3. Let's see exam late. (92.02 grams nitrogen oxide contains 28.02 grams nitrogen. Find the molecular formula of nitrogen oxide. We have grams of nitrogen oxide, so we have first MR. For nitrogen oxide, MR is equal 14.01 plus 1 times 1 plus 16 times Y. We have the relationship which find from the molecular formula. 1 mole of nitrogen oxygen is equal with MR grams, contains 14.01 grams of nitrogen. Also, we know that 92.02 contains 28.02 grams nitrogen. So we have the relationship from which we find the Y. And, of course, the molecular formula. So we find Y is equal with 2. Άρα, so the molecular formula of nitrogen dioxide is nitrogen oxygen 2. Example 9. Metal salt has molecular formula metal 3 nitrogen 2 and 403.8 grams of salt contains 8 times Avogadro constant nitrogen atoms. Find the atomic relative mass of metal. Identify which chemical element it is. Let's see the solution. We're interested for grammars with chemical compound, so we find first MR. MR is equal 3 times AR of M plus 2 times 14.01 is equal and we have the relationship from between the quantity of chemical compound and chemical element, nitrogen. 1 mole of the chemical compounds contain 2 times Avogadro constant, nitrogen atoms. We know n mole of compound contains 8 times Avogadro constant, nitrogen atoms. So we find the number of mole of chemical compound, which are 4. We know that the number of mole is equal with mass divided with molar mass. So we have and we replace the values. So we have and the result is AR of metal is equal 24 plus 31. And then from periodic table we find that is magnesium. These are some exercises, some examples in the mole concept. Thank you for watching, and I hope to help you. Thanks for listening, and more IB chemistry videos to come. If you like the video, and you can support me on Patreon. Thank you.